Trig functions part 1. To begin, trig functions. So I'm referencing this graph over here when I go through this description. It says, let theta be any angle in standard position and point P at x comma y be a point on the terminal side of theta. Let R represent the non-zero distance from P to the origin. So here is R. Starts at the origin. It's the length to this point. And we previously, or what we just talked about, was labeling this point as point P. So the equation to find the length of R is right here. It says let R equal the square root of x squared plus y squared. And of course, this cannot equal 0. If this is the case, then you have 6 trig functions. Your trig functions are as follows. You have sine, that's how you pronounce this. So it's pronounced as sine, which is equal to your y value. And when I'm talking about y value, we're talking about the point, so the y coordinate of the point, divided by r, and r is found by this equation we just talked about. Next, we have our cosine value, which is the x value of the point P, divided by r. This is pronounced as cosine. Next, we have tangent of theta, which is equal to the y value divided by the x value. Over here, we have cosecant, which is the opposite. So notice that these flip. So cosecant is r divided by y, which is the opposite of sine. We have secant, which is the opposite of cosine, and secant is r divided by x. And lastly, we have cotangent, which is the opposite of tangent. That means it is x divided by y. All right, and just to clarify on the value of r represents the radius of a circle, and it's the length from the center to the point. I'll actually add that as a note up here. Okay, if we look at the first example, it says given a point on the terminal side of an angle, find the exact values of the 6 trig functions of theta. So before I start, I'm just going to sketch the coordinate plane. This is strictly a sketch. So my point is at 8, -6. That means if I was to guess where that would be, I'd be looking at a point right here somewhere. Okay, so if we're sketching an angle in the coordinate plane, we always have our initial side on the positive x-axis. You should all know that at this point. So we have our initial side. And now the terminal side goes from the center through that point. The directions do say that this angle is in standard position. Standard position is a positive angle. So we're looking at a positive angle in the coordinate plane. All right, we know that this point right here is located at 8, -6. But what we don't know is the length of r. So we need to find this length that I just highlighted in green. We're looking to find what is r. So in order to calculate that, we use the formula I gave you above, up here. R is equal to the square root of x squared plus y squared. Your x value and your y value are the values that you use to plot the point. So it is these values here. Okay, so to start filling this in, I have r equals the square root. X squared would be 8 squared plus y squared, which is negative 6 squared. This simplifies to 64 plus 36 underneath my square root symbol. 64 plus 36 is equal to the square root of 100. Therefore, r is equal to the square root of 100, which is 10. Remember that we're looking for the radius. The radius has to be a positive value. So of course, the square root of 100 could be positive or negative 10, but we only want this positive value because we're looking for a distance, and distance is always positive. Okay, once you find the value of r, now you need to find the exact values of the 6 trig functions. Before I do that, I just want to make a note for other problems, not this particular problem. But if you can, or if you can't simplify the radical to a perfect number, then you need to just simplify the radical expression. And you'll see that in different problems. So actually, I think the next on your own section problem is like that. Okay, we just did the first step. So we just found r. The second step is to find all your trig values. To find the 6 trig values, we're going to use the fact that x is equal to 8, y is equal to negative 6. That's your ordered pair. That's the point, 8, negative 6. And the r value that we just found is 10. So to find the 6 values, we're going to use this table above. It tells us exactly what to do. At this point, it's really just plugging in your values and simplifying. So the first one, I always start with sine. I go right in the same order as this table. So sine of theta is found by y over r, which in this case is equal to negative 6 over 10, which simplifies to negative 3 over 5. That's your first solution. The second one is going to be cosine. Cosine of theta is found by x over r. X is equal to 8 and r is 10. 8 divided by 10 simplifies to 4 over 5. And you should be leaving these as a fraction. The third one is tangent. Tangent is found by y over x. Y over x is negative 6 over 8, which simplifies to negative 3 over 4. Next in my table is cosecant. Cosecant of theta is r over y. R is 10, y is negative 6. That simplifies to 5 over negative 3. Next is secant. Secant of theta is r over x, which is 10 over 8. 5 over 4 is the simplified answer. And the last one is cotangent. Cotangent of theta is x over y, and x is equal to 8, y is equal to negative 6. That simplifies to 4 over negative 3. Okay, if you're wondering about theta, if you don't remember, we did use that in geometry, but if you forgot what theta is the angle measure. So take a look at my sketch of a graph over here. Theta would just be representing whatever angle this is. Of course, we don't know what the angle is, but it represents whatever it is. So if it's 100, no, in this case, maybe it would be like 340. If the angle was 340, theta would be representing that. Okay, I'm going to go over one of the on your own questions just so we have another example. And then the last one or the second one you can do by yourself. I also want to just make a quick note that's important for future problems. You can never have a zero in the denominator. So when you're finding your 6 trig values, if you end up with something such as 4 over 0, this is undefined. So you cannot include that as a solution. However, if you end up with 0 over 4, that is just 0. Okay, you're going to see problems that utilize these, so make sure you know the difference between an undefined solution and a zero solution. All right, I'm going to look at number 1. So we have the point at negative 6, 6. So right away, I know that I have an x value and a y value, but I need to find my r value. So the first step is to use the formula. R is equal to the square root of x squared plus y squared. And I'm going to substitute in my x and y values. My x value is negative 6 squared plus positive 6 squared. That would be 36 plus 36. And 36 plus 36 is the square root of 72. Now 72 is not a perfect square, but it does have a square factor. So we can simplify the square root of 72 by writing it as the square root of 36 times 2. And then the square root of 36 is 6. Oops, hold on. The square root of 36 is 6. Left over is the square root of 2. That is your r value. So the square root of 72 is not a perfect whole number, but we can simplify it to 6 times the square root of 2, which is what we need to do. Once we find that value, the second step is to find your 6 trig values. To find the 6 trig values, you use the fact that x is negative 6, y is positive 6, and r is what we just found as 6 times the square root of 2. Starting with sine of theta is equal to y over r, which is equal to 6 over 6 times the square root of 2. Now you have to be careful here because you can never have a radical in the denominator, which is why I wanted to go over this problem. So you are going to have to simplify this. You're not done at this point. The 6 and the 6 cancel, which right away I see that. But in order to rationalize, which we already did this year, so hopefully you remember, I need to multiply the top and bottom by the square root of 2, giving me an answer for a numerator of the square root of 2, and the denominator would be the square root of 4, which simplifies to 2. So the sine value, sine of theta, is the square root of 2 over 2. Cosine of theta is found by x over r, which your x value is negative 6, your r value is 6 square root of 2. So again, I recognize that the 6's cancel, but I also recognize that I can't have a square root in the denominator. So I rationalize by multiplying the top and bottom by the square root of 2. My numerator still has a negative sign, so negative square root of 2 divided by the square root of 4, which is 2. The third trig value is tangent. Tangent is found by y over x. That would be 6 over negative 6. 6 divided by negative 6 simplifies to negative 1. Cosecant, abbreviated CSC, is r over y. That would be 6 square root of 2 divided by 6. And your 6 values cancel. You don't have to rationalize because your square root is already in the numerator. So when you simplify by canceling those values of 6, you're left with the square root of 2. Next we have secant of theta. Secant is r over x. 6 square root of 2 divided by negative 6. We're left with the square root of 2 divided by negative 1, which is just negative square root of 2. And lastly, you end up with cotangent, which is x over y, and that would be negative 6 divided by 6, which simplifies to negative 1. And those are your 6 trig values. So be careful, make sure you rationalize when you need to, make sure you simplify when you need to. But other than that, you just use the formulas I gave you on the first page, you plug them in, you simplify. All right, next, or you can finish number 2 in the on your own section by yourself. The answer key is on my website, or I can go over it during the live session if anyone wants to log on. But we're going to go over the last example set, which is using the unit circle. And today we're just going to touch base on this. During the next lesson, we really go in depth with the unit circle. So over here, you see that I sketched a quick unit circle, but my description says that the unit circle has a radius of 1 unit and a center at the origin of the coordinate plane. Any right triangle formed by the radius of the unit circle has a hypotenuse of 1. So what this is saying is that you don't need to find the r value. If it tells you that you have a point on the coordinate plane, anywhere in the directions, but it does have to say, sorry, a point on the unit circle in the coordinate plane, but it does have to say that. If it tells you or if it mentions the unit circle in the description, then you automatically know your r value is 1. Yes, you could continue to go through the solving for r, which is square root of x squared plus y squared, but you don't have to because if it mentions the unit circle, r value equals 1. It's right here. Every single time. It's just a common term for the unit, or a common factor for the unit circle. So this is the same type of problem as example set 1, but when the point is on the unit circle, the radius is automatically 1 and you do not have to solve for r, as a quick recap there. So the example set, it says given a point on the unit circle, right there, unit circle. So as soon as you see the word unit circle, r equals 1. If you don't see that word, can't assume that, but as soon as you see unit circle, r equals 1. Find the exact value of the 6 trig functions. All right, here is your x value and here is your y value. So if I list all of them, my x value is negative 1/2. My y value is the square root of 3 over 2. And my r value, because it's on the unit circle, automatically equal to 1. We're using the same 6 trig functions, starting with sine of theta. Sine of theta is y over r. My y value is the square root of 3 divided by 2, all over my r value of 1. Well, any number divided by 1 is itself, so my solution is the square root of 3 over 2. Next, we have cosine of theta. Cosine is x over r. My x value is negative 1/2, r value is 1. This simplifies to negative 1/2. Next, we have tangent. Tangent is y over x, which is square root of 3 over 2 divided by negative 1/2. And when you're dividing a fraction, like we learned earlier this year, it's the same thing as multiplying by the reciprocal. So you multiply by the second fraction flipped. So square root of 3 over 2 multiplied by negative 2 over 1. Here you can see your two values cancel. The numerator is negative square root of 3. Denominator is 1, which we don't need to write. The fourth value is your cosecant of theta. Cosecant is r over y. This is equal to 1 over the square root of 3 over 2. When you're dividing by a fraction, you can multiply by the reciprocal, so 1 over 1 times 2 over the square root of 3. The only problem here is that you do need to rationalize this. So you need to multiply the top and bottom by the square root of 3. This simplifies to 2 square root of 3 divided by the square root of 9, which simplifies to 3. Secant. Secant is r over x. R is 1, x is negative 1/2. Multiply by the reciprocal, you have 1 over 1 times negative 2 over 1, and that simplifies to negative 2. And lastly, we have cotangent. Cotangent is x over y, and x is equal to negative 1/2. Y is the square root of 3 over 2. Multiply by the reciprocal, we have negative 1/2 times 2 over square root of 3. Your values of 2 will cancel. That leaves you with a fraction of negative 1 over the square root of 3, of which you have to rationalize by multiplying by the square root of 3. Your numerator is negative square root of 3 divided by the square root of 9, which simplifies to 3. There is your cotangent value. Okay, I'll be live at the end of class if anyone has questions, or you can email me, but that is the lesson for today.